Hello and welcome to the first lab for Info 655 Digital Preservation and Curation. During this lab, I'll be introducing the command line, which I think is one of the more unique parts of this class, and I think it's valuable. Even if you don't want to use the command line after this, or you don't have the opportunity to use it in the future, it is something that offers you a new view of using a computer. The analogy that I like to use in my head is that it's a lot like transportation, that the pieces of software that we generally use day to day are kind of like public transit. They know what you want to do. They will take you to a very specific place, and they can do that for a lot of people at scale, and that's great. But what if you need to go to a slightly more off the beaten path place? What if you have very specific needs, or you want to move more things than you can fit onto the back of a bus? Well, in that case, you need to have something like a bike or a car or something that you are using yourself, or maybe you hire a vehicle. Maybe you ask somebody to build some software for you. But it can be very helpful to be able to do some of this yourself. And the command line is a place where we are given some of those tools to start directing the things that we want to do on a computer ourselves. However, it does require that we learn how to use them, that we learn the rules of the road, that we learn what these tools are capable of. And that requires some amount of, I would say, bravery on our part to go out there and try it and to see where it goes. Some of you may come away from this really enjoying it. Some of you may come away from this saying, cool, that's not for me. Your grade in this class is not dependent on how much you love the command line after this class. This is mostly to give you the exposure so that you can see what's involved in some of these processes. So the key points for today are that we're going to learn a little bit of the syntax of the command line so that when you see a command, you can say, oh, okay, I understand a little bit of what's going on here, even if I've never seen this command before in my life. We're going to learn a little bit about paths, which are an extremely important tool for us because when we're talking about digital collections, we are talking about files, and paths are where those files are located. And then finally, we're going to set up for installing additional tools that we will use in future classes. So, first of all, what is the command line? Well, number one, it's called a lot of things. You might have heard of bash or shell or terminal or CLI or other stuff. Technically, there are some shades of difference in those different things, but when you hear people talk about it, for the most part, it doesn't really matter to us. All of these things refer to the same thing, which is this Blinky tool that people like to call the command line. Let me pull one up. There we go. There's a command line. It is blank, and it's asking for us to do something. We just don't know what yet. So we're going to go into that. Now, the command line, what it is, it's a method for us to interact with a computer by typing in a command. So rather than use a mouse to click on buttons or a finger to click on buttons, we are typing in commands to the computer and instructing it to perform various actions. This is relating back to how computers were built, the fact that we put in things through punch cards or eventually type things into a monitor and entered in our requests in that manner before people invented things like the mouse and the monitor. That the only way that we were able to interact with a computer was through text. And so a lot of low-level stuff is available through the command line because that is the foundational model of computing. Now, in this class, whenever you see something written in this Courier font, that is a command, and generally you should be able to copy paste that and it should be able to work. Sometimes it might not work because it depends on having to do a few things in order, but just to call attention to it, I always try to put it into this font. Now, why should you use the command line? I mentioned before that I think it gives you exposure to being able to have a little bit more direct control of the computer and to be able to work on things a little bit more independently from what softwares may give you the affordance to do through their interface. Well, here are some other reasons to make it more specific. Number one, could make your job easier. This is the thing that really brought me into the command line, is that there were actions that I had to do for work that were extremely repetitive, and I had to click, 5 buttons and 5 different dialog boxes over and over again, and it was very annoying, and honestly, I made some mistakes while doing it, and then I found out I could do that same process by typing in a command, and typing in a single command rather than clicking a bunch of boxes. So that was really great. And it allowed me to even get into automation, which is what computers are super, super good at, and I am not that great at. Secondly, some tools are only really out there as command line programs, or the full extent of the power of the program is best available through a command line. So sometimes if there is a thing that you want to accomplish for a project or for work, you have to you'll find advice and they'll say, FFmpeg is the best way to do this. Well, there are some interfaces, but most commonly people use that tool through the command line. So you would be forced to be able to interact with that and be a little bit more comfortable with that. And then finally, and this was the case for me again, it can be an introduction to programming, and it can really take something that was taught in a class as here's a skill that could be useful at some point in time, and turn it into, I have a specific use case. I need to be able to do this, and I don't want to waste my time doing it, or I don't want to keep clicking on this 20 times over and over again. And instead, I'm going to take a little bit of time and I'm going to learn how to do this via a little bit of programming so that I don't have to focus on this and I can work on other things that I need to do. So it's an interesting thing. You are working with a computer, issuing it commands, getting output from it, and then performing more work. If that's something that really ignites your curiosity, that's fantastic. It could be very useful. If that's not, then you at least saw how some of these things work. All right, but that's my excitement about the command line. I will be cautious about it. As I mentioned, it is potentially intimidating. Once again, looking at this thing, it's just a black box with a cursor. I can type letters, but what happens when I press enter? It just says command not found. Well, what command can I put in there? This is part of the reason why we have graphical user interfaces, is because we display actions to users so that they know what a tool is capable of doing. The command line doesn't do that. The command line doesn't even tell you what tools are available. You have to learn how to write a command to find out what tools are available. So that can be intimidating. Part of the reason for this class is to show you some of those things so that you can not have to face down that kind of cliff in learning. And yeah, it can be a cliff, but once you start learning things, it becomes a little bit easier. For instance, here's a command. It has some dashes, it has a number, some letters, a URL in it, WGET, whatever in the world that is. This might look very arcane, but within, a day or two of using some commands, you will very quickly start picking out what different portions of this could be able to do. You'll have some resources that allow you to figure out how to figure out what those specific things mean. And you could actually puzzle out what this thing does. And in fact, I'll walk through this. wget is a tool to get things from the web. This -mp says, don't get the parent. We'll talk about what that is. -l1 says, get one level. -a means download as a zip in this case. And then this is what we're downloading from. So we're saying don't download this website, but download every link that comes off this website and download it as a zip. And yeah, this particular website has hundreds and hundreds of zip files on it that I needed to download. And this one command was able to do that. And I was able to walk away from my computer and do something else, which was very, very useful. Now, this class will not make you an expert. I'll introduce things. And, if you find it interesting, if you find it useful, there are a lot of great resources to keep digging into it. Everybody's journey with this kind of stuff, it's back to that analogy of getting your own transportation. it's kind of what you make of it, and you're probably going to have a different use case than anybody else in the world. So you compare, you swap notes, but your specific needs are going to be what they are, and you will develop as an expert in the thing that you need to be able to do. So number one, how do we get to the command line? If you're on a Windows machine, I've given you instructions on how to get to Windows Subsystem for Linux. If you're on a Mac, what you can do is you can press the Command key and the spacebar to bring up Spotlight, type in terminal. There we go. And there we go. I already have my terminal open, but yours should open in a window that looks like this, or maybe it's white with black text. Now, this terminal is the default shell for Mac OS. And as I said, on Windows, there's a couple of things, but we use Windows Subsystem for Linux there. If necessary, I will swap between other things just to give a little bit more, diversity in terms of the interfaces that we see. So, as I said, I am a Mac user for the most part. I do use Windows, and I can provide some help with it, but for the most part, I'm most familiar with this kind of command line, so that's why I encourage everybody to be using this or Windows Subsystem for Linux, but I can provide help if you need some with other platforms. Now, okay, so that's some setup for what we're doing here. Once again, just as a reminder, commands will be in this Courier font, and generally you should be able to copy and paste these things. However, I will encourage you to type them. It is great to build up that knowledge. How do I type that dash key without looking at my keyboard? How do I hit some of these other keys like my colons or my semicolons? Things that I don't use as often in daily typing. The pipe character, for instance, or this squiggle character. It helps to type these things out because your fingers will learn where they are on the keyboard. So I encourage you to type. I will be typing all my commands as much as I possibly can. You will see my typos, and I will type these things multiple times. So don't feel like you have to be at my typing speed. All right, so as you're typing these things out, you will run into errors. As I said, I run into errors too. There's a command like ls. What if I type in LSS? Whoops, that's a typo. You'll see it says command not found. You might do this. We might be running a thing about ffmpeg and you forgot to type one of the Fs, and so it will say command not found. Two things about this. Number one, sometimes that tool does not exist. That is a typo on your behalf or on my behalf. So, LSS is not a tool that exists. It's not the one that I want. I want ls. This is the listing command. Sometimes it could be the case that we haven't installed that tool yet, or that is something that needs to be updated. So I think I have all the tools for this class installed, but just in case, if we're running something like ffmpeg and it says command not found, then you probably have to install it. And we'll learn by the end of this class one of the ways to install new tools as necessary. So always make sure that your commands have run successfully, all of your commands. Sometimes they depend on one another in the labs here. Number two, make sure that the command is typed in correctly and that the tool is installed. Either one of those errors will cause a command not recognized response on your terminal. And if all that stuff is not working, let me know. I can help you out. All right, so a little bit of safety. None of the things that we do in this class are going to alter your computer in any way that could cause damage to it. But it can be, this is a weird screen with a lot of text, and it can be intimidating when it just starts running things and you can't get control back of it. So for instance, here's the thing. This is ping. It will run pinging this server from Google at 8.8.8.8 until my computer runs out of power. And I have lost control of the keyboard. It doesn't even say command not recognized because this is now in an output mode and it's just writing data to me. And I have to tell this program to stop in order to write a new command. What I can do if something like this is happening, whether it's because I'm done with this tool, or this tool is doing something I don't want, or it's taking longer than I think it should, and I just need to get control back, Control C. Control C will stop most commands dead in their tracks, and you will have control of your keyboard again. Now, if that does not work, which it does work on ping, but in case you're using a program that for some reason Control C is not working, Control and Z, that will work, and you'll see it says suspended. So this is kind of pausing the program for you. And you can just ignore it. Whenever you close your terminal, that program will be completely closed at that point in time. So again, if tool is running, you need to stop it, Control C. If Control C doesn't work, Control Z will typically work. On a PC, if you're using Windows Subsystem for Linux, Control Z and Control Z are the way to go. But if you're using some of those other terminals, just for your knowledge, Control C is your first stop, and then Control Break. And then the final thing is you can always close the terminal. So any program that you run in a terminal depends on that terminal to be open. And so when you close that terminal, the program will stop. So in case you just say like, stop this thing now, hit that big red X in whichever corner it is, and it will be over. All right, so what are the components of a command? You've already seen a couple of commands here, ping, ls. Well, what do commands look like? Generally, they have a couple of parts. Number one, they have the name of the tool being used. So ping, that's the name of a tool. It sends a small signal to say, hey, are you out there, to another server. It might have the name of a subtool. Ping does not. Ping is a very simple, one-use tool. It might have some flags to modify how it runs. I think ping does have flags. I never know what they are because I just use it for this one purpose, which is, does that server exist over there? And in order to say, hey, ping, I need you to contact that other machine somewhere else on the internet or on the network, I need to give it some input. So in this case, I give it an IP address. I could also give it a URL. So I could ping google.com. There we go. It takes a little bit longer, but start it up and it's saying, yeah, here it is. It takes about 20 milliseconds for the ping to go out to google.com and to come back and say, yes, google.com is a running website. Let me close that one off again. So every command has these components, and we'll see some of them. And as you start to get familiar with these commands, knowing this syntax can help you pick apart an example that you see and understand, what are the parts that I know and what are the parts that I should learn about before I run this thing. So we're going to run a couple of commands then, and we're going to see different kinds of output from all of these commands. So the first command I'm going to run is cd squiggle. If you don't know where the squiggle key is, it is the key to the left of the number 1 key, and you press shift to get the squiggle. If you don't press shift, you get this, I forget what this one is called. Tick mark is what I call it. So shift and you get this squiggle sign, and nothing seems to happen. So some commands will change the state on your computer in some way. They do not give you output directly. They just change some portion of the terminal or your terminal session. So I could actually cd to downloads. You'll see what happens is, in my case, this changes. Suddenly the squiggle looks like it downloads. And what cd says is actually this is changing directories. So I'm changing directories from this squiggle directory over to the downloads directory. And if I want to change back, I will change back to the squiggle directory. Squiggle is my home directory. I could run this thing. So this is a tool. I'm going to put in some input, in this case the word hi, and I get some output. It echoes back whatever input that I gave to it. I can echo 1, 2, 3, and it will say 1, 2, 3 back at me. Finally, ls squiggle. So again, we're going to be working with this path, this squiggle thing, but in this case, you've already seen this. ls is the listing command, and it says, hey, I want you to list the files in this directory, in the squiggle directory. And this is what it looks like on my computer. It will look different on your computer. So each of these commands, these are relatively common commands, and it's useful to know what cd and ls mean. And it's always useful when you see a command to just puzzle through it and say, okay, what parts do I understand and what parts do I not? All right. The other thing that I will be introducing through the command line is some good practices to run, just things that are not obvious when you're staring at this, blank box, but are very helpful in using the command line. So for instance, there is a history portion of the command line, and this history function allows you to recall past commands that you ran, which can be useful for all kinds of purposes. So the way to access this is you press the up key on your keypad, and that will go one back in your history. You can continue pressing that up key, and it's kind of like a back button. It will show you commands that you ran in the past. You can, of course, press the down arrow, and you can come back to the last command that you ran or to your blank screen. And this can be very helpful because what if you typed a command and you're like, actually, that was the wrong thing. I wanted to type hello. Great. I just saved myself some keystrokes. I didn't have to type out this whole thing. Now, echo is a fairly short command, but you can imagine when you run a really, really long one, you could, have a small typo somewhere. What if accidentally I was listing things in my downloads folder and I skipped a couple letters. I'm like, oh man, I don't want to type all those letters. Well, I can bring it back from history and then do that small edit there rather than type everything from scratch again. So using your history can really help you out in a lot of ways to, fix small mistakes or run the same thing over again. It's really, really handy. All right, so we're going to be using that history command. You will see me use it all the time. Whenever you see a command just pop out of nowhere, oftentimes it's me just running the last thing from my history and just tapping back a few to get to a command that I wanted. Now let's talk about some inputs. We already looked at a couple with the cd command, the ls command, the echo command. And when we're talking about inputs in this class, most of the time we're talking about file paths. We work with digital collections. Files are the things that digital collections are made of, and file paths are how we name where those files are located. So I think file path is a great name because the path part says, okay, here is a journey. I'm going to give you a sequence of directions by which you can go and find that file. And the most clear directions that I could give you is starting from the very beginning of our storage system, from the highest point in the storage hierarchy. And I'm going to give you one path or one folder that you have to go down until you finally get to that path. That kind of a file path is called an absolute file path. It starts with the very highest level directory in your storage, and it goes down to the file or folder that you want to reach. Now, that's one way of doing this journey. We could also say, well, okay, what if I want to give the path from one folder somewhere on my computer to another folder somewhere else on my computer? Well, that would be a relative file path. You're not starting from the highest part of the hierarchy. You're starting from somewhere in the middle, and you're going to somewhere else in the hierarchy. So we're going to look at a couple examples of this, but this absolute versus relative thing is something that took me a little bit of time to understand. So pay attention to some of the characteristics of these paths. Now, when you're on a Mac or on Windows Subsystem for Linux, you will see file paths that look like this. They are separated by slashes that lean to the right, and between each of those slashes is the name of a folder. So an absolute file path here is /users/ your username /downloads. So for me, that would be I'm going to list the contents of my downloads folder. So /users/ crab /downloads. Bam. And there are my downloads. Now, some special characters that help you determine what's going on with these different paths. Number one, the / is your root directory. So any path that starts with a / is an absolute path. This will be uniquely kind of identify the path to that file and will work no matter where you are on your computer because it doesn't depend on the current directory. Any path that doesn't start with that is a relative path. So this is my absolute path to my downloads folder, but I could make a relative path to it as well. Let me back out to my home folder. So a potential relative path is downloads because the downloads folder, the downloads folder is a child of the home folder. Now another potential path to this folder is, let's see, I could go up one folder and then I could go back into this folder and then I could go to my downloads folder. And that still works. Now, if I changed my folder, if I went up one folder for my working directory, well, let's go into my history. This doesn't work. This other relative path doesn't work. Neither of those things work, but this absolute path will always uniquely identify that directory. So absolute paths can be very handy because they work no matter where you are on your computer. Relative paths can be nice because it's shorter to type. And if you are aware of your current working directory, it's relative to that. So you saw this, the .. is the relative path to the parent directory, so back up one folder. The squiggle character is actually a short working version of your home folder, which is /users/username. In my case, crab. You see that we go to the same location. The asterisk character is a wildcard. We'll see that in activity. And then finally, the space character can be very complicated, and I'll show you why in a little bit. Now, just running through some examples here. We have this absolute path, but that's the same as your home shortcut /downloads. You can do / you can go up and down paths as much as you want, and that is fine. You can use a wildcard to list a whole bunch of things, kind of using it as a filter. Let's look at this because it's always fun to see how many PDFs you have. There we go. That's all the PDFs in my downloads folder. I could also say, hey, what are all the files that end with F? Oh, I have an RTF file in here. Nothing else that's super different. I can ask for the files that end with G. I have some installers, some JPEGs, some PNGs. That's what the wildcard character does. And then if you want to refer to a file with a space in it, you have to either escape those spaces with a / in the other direction, or you have to wrap it in quotes. So in this case, we have the collection management system collection PDF here. And so if I would like to list just that file, I would have to go, the collection management system collection.pdf. And it actually doesn't like that path, probably because I typed something incorrect, which I'm going to jump ahead to one of the things that you could do to make this easier is something called tab completion. So as you're typing a path, most terminals include this feature. You can type in a couple letters and then you press the tab key and it will try to find a file that starts with those letters. So in this case, I typed THE and it filled out the rest of it. And I can use that to actually figure out, okay, so here's where my problem was with that past example. I had an extra F. So once I do that, I can actually get the command and I don't get this no such file found error. So space characters are always a little bit difficult. You can put this / here, you can wrap them in quotes, but in general, the easier way is to let your computer handle it. So one of the ways you can do that is the tab completion that I showed you. Another way I'll show you in just a little bit. This is, just if you're using on the PC, so I'll run through it, but most of it looks the same. The only difference is that the slashes go the other direction. One of those, two people pick two things, and now we're stuck with that idea 40 years later. The other thing is that on a Windows machine, there are multiple root folders. Each one is attached to a specific hard drive or volume on your computer. So C:/ or D:/ are very common ones, but you can have as many drive letters as you want on a Windows machine instead of just that singular / for the root folder on a Linux or Mac machine. But otherwise, a lot of these special characters are very, very similar, and we see a lot of the same examples with Windows paths if you're using something like PowerShell or the CMD terminal. The one other thing that I want to point out for Windows, since we are using WSL, is that because it is a Linux installation running on a Windows machine, that means it needs to mount all of the Windows drives as using a Linux file system. And so instead of using these like C:/ characters, all of the drives are mounted under /mnt/ drive letter, and then otherwise the path remains the same. All right, but just running through these paths, it's always good activity to think about the relative and absoluteness of it. Squiggle, I like to consider this a relative path. Squiggle /downloads, relative. Downloads, this is relative. It does not start with that / character. /downloads, this is an absolute path. /users/, that's an absolute path. And so these paths will function differently depending on where you are on your system. So again, if I look for the downloads folder from my users folder, there is no folder called that in this folder, as you can see. If I look for the /downloads folder, that is an absolute path, but there is no folder called /downloads, so that doesn't work. However, using something like /users /crab /downloads, yeah, I can run that wherever I am on my computer, and that will work. All right, so I promised another way to deal with file names that have spaces in them, and so let's do that. I'm going to open up a Finder here, and you'll see, great. Here's Finder. Yeah, that's a file name with some spaces in it. One of the ways I can deal with that is instead of typing it out, I can drag it in, and you'll see it pulls in the absolute path to that file, and it escapes all the spaces in there. So again, start typing a command. Is there anything else I want to type? This is a command, and I can drag this in, and it tells me, okay, it gives me some output about this. So it handles that for me. I don't believe this works as nicely on the Windows subsystem for Linux, unfortunately, but just as a reiteration, you can always have, personally, my favorite way to do this, which is using tab completion. So again, tab completion, the way that works is that you start typing a path. Let's see, in this case, I'll give it a D, and I'll say, oh, there's a file called Digital Power Pyramid Invoice, etc. Maybe that's the thing that you're looking for. I could also ask for, okay, I'm going to give it RA, and it says, oh, well, there is a file, but actually that is not the full file name. There's 2 files called this. I downloaded it twice, and so if I keep pressing tab, it will start suggesting either of those files, and I can, decide, oh, I want to see that one, and that selects that file. So tab completion, extremely handy. It takes care of capitalization, typos, all kinds of things. When in doubt, always just tap that tab button, and it will make sure that the path actually works. And you will see me use this all the time. Whenever you see a path just jump out of nowhere, that's me pressing that tab button. So it is, get used to tapping it with your pinky key or pinky finger, because it's just really, really handy. All right, so let's try another activity here. Number 1, this is always a little bit scary, but let's look inside of the downloads folder. Sorry, I'm in the wrong folder. I'm going to back out. I'm going to go to my home folder here. So ls squiggle downloads. I'm pressing tab because downloads is too long for me to type anymore. Wildcard PDF. I don't know, I always find this interesting to see what has piled up in my computer over time. I have my taxes. I have some bank statements. I have a syllabus from a very old version of this class. I have a couple of other things, a passport application. Yeah, so pretty boring life that I'm leading on this downloads folder. But you might see some different things. On the other hand, let's try something else. Let's look for see if I have any folders called my something. In the case of any Mac user, most likely you won't get anything. And so I'm hitting tab here and it doesn't fill out because there is no folder that starts with my. And so that's a good indication to me that I'm looking for the wrong thing in this folder, or maybe I'm in the wrong folder currently and I'm not going to find anything. If I put in a capital M, it says, yeah, there's a movies and music folder, but there's no my movies or my documents folder like there would be on a Windows machine. All right, so that takes us through using some of these commands. But we're just reporting things out. What if it would be handier for us to get some of the output from one of these commands and put it into a file so that we can manipulate it or use it in some other program? Well, the nice thing about the Linux terminal is that it's all based on text, and there's some really direct shortcuts to taking the output of any command and putting it into a file. So to do this, what you have to do is use this arrow character, this right angle bracket. And what that acts as is a redirection to say, instead of printing out the output of this to the terminal itself, we would like you to take that output and put it into a file. So we take this angle bracket and we say send it somewhere else. And where do we send it? Well, we're going to give you the name of the file to send it to. So for instance, I can type in, hey, hi, this is my first file. I'm putting this in quotes because there's spaces, and spaces will make my computer confused. So putting this in quotes tells it this is all one piece of input. Treat it as one solid thing. If I run it without the arrow, it just prints out directly to my terminal. If I put in this arrow, well, then I can give it a file name. I can say, we're going to call this hello.txt, and I don't get that output. However, there is a file here. There is a hello.txt. I'm actually going to go ls-l hello.txt. And you'll see here, I just wrote this thing. And if I want to see inside of it, I can run this command cat, which is short for concatenate, or catalog. I'm not exactly sure, but to me, it's just I run cat and I get the contents of a file. So if I run cat.hello.txt, hi, this is my first file. Now I can redirect that to any folder I want, but I have to give it the path. So I could use an absolute path. I could say users crab desktop and put a slash there. And again, I don't get any output, but I can look at this file over on my desktop, and there that is. I can change some of the context here. I'm going to make this my second file. And instead of using this absolute path, let's put squiggle / desktop.hello.txt. And I'm going to, again, run this same command, but, I just overwrote this file. So by running this command and redirecting the output to the same file, I've actually overwritten it. This data is gone. I can't really recover this unless I try really, really hard to do so. But this data has been overwritten. This file no longer exists. This is the new file, and this is the new contents of that new file. This redirecting thing works wherever you are on your computer. If you are getting some kind of output from a command, you can redirect it to a file. We'll put this back to our original hello.txt. You'll see I'm no longer getting those ping outputs onto the terminal, but if I press Control-C and I cat that file, there is all that data that used to be being printed to the terminal. So this is a way for me to take sort of real-time output and store it a little bit so that I can use it for other purposes. And we're going to be, ripping out some technical metadata from things or getting other kinds of output, and storing it off to a file can be a very handy thing to do. Now, as I mentioned, if you want to read the contents of any file, you can use this cat command. So we used it to do cat.txt. Let's see what else I have in here. Payload.bin. Ooh, that's an interesting file. I'm betting that this is not a text file. So when we cat this one, we're going to see a bunch of funky characters as the terminal tries to interpret random bytes as text. Yep. So that's a strange file. It started putting out a bunch of attempts to understand what the context of that file was, but let me clear this all off. Whew. Ooh, messy file. Okay, computer's okay. But yeah, there's cat will just try to display the contents of something. Ooh. Oh wow, that's an interesting side effect. Cat will try to interpret a file as text and print that out to you. It works with text files. I believe I had an MD5 file here. My MD5s.txts. You'll see, yeah, this is another text file, and it can actually interpret that data and print it out to us. Now, that's our initial introduction. The last thing that I want everybody to do is start to learn how to use a package manager. If you're on a Mac machine, we're going to have to actually install that package manager. What a package manager is a tool to help you download new tools, install those tools, keep track of what tools you have installed on the command line, sometimes GUI tools as well. Linux actually has one pre-built that we're going to be using, but on a Mac, we have to install one. The one that we use is called Homebrew, and in order to install it, what you do is you type in this command. So I'm going to have to actually type this because I can't copy paste from here easily. So what you do is you type in user/bin/ruby-e, quote marks, $, curl, fs, capital S, capital L, and then https raw github. Whoops, and there's a typo. This is a command that's very okay to copy paste because it's a lot to type out. github-user-content.com/homebrew/install/master/install, and running that. And what's happening is that it's saying that you can install this using this command instead. It's actually recommending. So they've updated it since I wrote these slides. So I'm going to copy that, and I'm going to stop this command. So that stops it. And I'm going to run this command instead that the Homebrew people are recommending. I'm going to run that. Sorry, let me scoot this back up. And you can see it's asking for my password. This is your user account password. It's just to say, yes, I'm giving permission for this tool to install. So I'm going to type mine in. And you will see it continues going. It says, hey, return to continue. Press another key to abort. We're going to press return. And now you're going to let this tool install. It takes about 5 to 10 minutes. And once it finishes installing, you should have a working Homebrew installation. One of the ways that you can test this, that it has been installed, is that you can try to install additional tools. So mine is actually already installed, so it finished pretty quickly. Just updated my Brew installation. So in this case, I'm going to use the Homebrew tool, which is called Brew. I'm going to use a subtool, which is called Install. And then I'm going to install some additional utilities. So core utils. This is a software package with some updated utilities. I run this. And again, I have these things installed, but it's saying, oh, there's 9.1s available. So goes ahead, it downloads those things, it updates everything, and fantastic. I have my latest version of Core Utils. So once you have that running, you should be good to go. For Windows Subsystem for Linux people, Core Utils is already up to date, so you don't need to install it, and we'll run through an installation during the next lab. Now, finally, I will say one other word of warning. You can delete files through the command line, but you delete things and they are super, super gone. There is no trash bin when you use the default rm command. So I generally warn people not to use that until they're feeling comfortable and confident on the command line. We do not use that command in this class. So just be aware that if you ever see somebody say, rm hello.txt, that file is gone now. I cannot recover that file except if I work really hard to do so. It skipped the recycle bin. So again, that is just a word of caution. Now that you've seen commands, you can recognize this rm thing and avoid it unless you feel you are comfortable enough to say, I know exactly which file I'm downloading, I'm deleting, and then go for it. But do be careful, because that is one of those commands that can actually change things on your computer, and which is why we're avoiding it in this class. Now, reiterating the key points from here. Number one, the command line, alternative way to interact with your computer. The commands that we looked at today, many of them you see some analog on a computer, going to your Finder, opening up a folder and listing the files in there, opening up a text file in a text editor and seeing the contents of it. Not that exciting, just an alternative way of working with a computer, but interesting for that. The other thing is we have this basic grammar of tool inputs, or tool name, and then inputs to change the performance of that tool. So whenever you're looking at a command, the first thing that you read is the command, and then the things that come after that will be modifying the behavior of that command. And then finally, when you run a command, the things that you will get out of that command are either some output, typically as text, a change in the state of the computer, perhaps changing directory or something like that, or output to a file. We did that when we redirected some of those programs to write a file to our computer. And we're going to be doing that in different ways throughout the rest of the lab. All right, that's it for the first lab. If you have any questions, please come ask me, and we will continue to do these things. So if some of these things still don't feel very comfortable to you, we're going to keep introducing it. We're going to keep working on it and building that confidence level with these things. All right, I hope you have a good rest of the day, and I'll see you in class.